Python is crucial for any aspiring data science as practitioner. In a real world where Python is now used for so many analytical projects, learning Python is one of the key key skills for every aspiring data analyst and data science or data professionals. So welcome back to the channel and welcome to Excel Island. And where the goal and objective is to learn and master Python over the next 100 days. And welcome back. And today is day 9. We are on the course called Intermediate Python in the career track section of the DataCamp platform. So this intermediate Python actually contains 5 chapters. We have matplotlib, we have dictionaries and pandas, we have logic, control flow and filtering, we have loops, and we have a case study that will be our first case study, which is the ACA statistics, since we started this Python learning journey on the channel also. So on previous live stream, which was day 8, so starting from day 1, we've covered quite a lot. So you could go to the live stream tab. Sorry about that. You could go to the live stream tab on the channel and catch up from day 1 when we got introduced to Python. We learned all about data types and variables. We learned all about lists, how to create lists in Python, and we also get introduced to some packages like the matplotlib package and the pandas. No, we've not got introduced to the pandas, the NP and NumPy package also. So we've covered quite a lot from day 1 to day 8. So on day 8, we actually started the pandas and dictionary chapters. So we actually did the dictionaries part on the 8th, which was all about which is an alternative to Python list. So dictionary are more like a Python list, but a better and alternative version to Python list. Because you can catch all about dictionaries on the 8th. So on today, day 9, we're just moving to pandas, which is de facto the standard data frame to work with tabular data in Python. So without further ado, let's get started and welcome to day 9. So also all the data sets or CSV files, Python files will be linked under the description. So do make sure to download those files so you can practice along with me. So I just go to the career tag section really quick here, so you could see what it actually looks like. So we are on the data analyst with Python career track. So when this fun way of learning started, when I said to start live streaming or this learning journey to encourage someone out there to get prepared and master their tech skills, I actually started with the data analyst in SQL career track, which ran for a 100-day period. We actually used a complete 100 days on the data analyst in SQL career track. So that's so we also went over to data analysis in Power BI, and I'm actually working on some projects in the background, trying to build portfolios so I can use to present and apply for jobs. So actually, I'm a top rated plus freelance data analyst on the Upper platform. So I've had major success on the platform, and I decided to upskill myself also against the upcoming year, so I can have some more technical and analytical skills to sell on the platform. So by the way, so if I just click on data analysis with Python, real quick, so you can see we have introduction to Python. We have almost just 15 courses to go, and we are still on the second course, which is the intermediate Python. So we've covered introduction to Python from actually day 1 to 4 or 5. So you can catch all we've learned about Python basics, Python list, functions and packages, NumPy, on the live stream tab on the channel. Do make sure to go to the live stream tab on the channel. Let me show you what that looks like really quick. So you can just go to this section. Sorry about that. So you can just go to this section here. You could see all previous lesson there. Okay, so let's continue from here. So we just continue from where we stop. We're actually on dictionaries and pandas. Okay, so let's continue real quick. Okay, so I have my Jupyter. I have my Anaconda launched already. So let me just simply launch my Jupyter notebook. So that is the environment we are going to be using to work on our own. Aside using the DataCamp or Python environment, so they have a PowerShell or PyCharm already. So I just go back here. So this was where we stopped from 4 days ago. I'll be quite busy a lot. So if you're not seeing me live streaming daily, probably I just have to attend to some important uh concepts or projects. So I try to schedule everything as much as possible. And sometimes my network just delays everything. I just have to I'm not just live so that my videos will not be lagging so you can hear me clearly as you're hearing me right now. Because I'm in a country where we have no choice than to at least find ways and manage what we have so we can actually get what we want. So on 4 days ago, which was day 8, we learned all about dictionaries and pandas. So you already learned about dictionaries in Python, focusing on their unique properties and how to manipulate them. So dictionary are like key value pair, you see. So when we define a dictionary, so you say Spain, we have Madrid in Spain, we have Paris in France, we have Berlin in Germany, we have Oslo in Norway. So you can actually add more to the dictionary. So this is a key value. So you see, they are key value pair, key value, I call it key value pair. So you can catch all about that on the 8th. You can actually add more to the key value pair by just pointing to the dictionary name. Then you open a square bracket. You add your key value, your key, then you equate it to the value of the key, and just like that. So let's talk all about today. So I actually have my notebook somewhere. Come back to that later.
As a data scientist, you'll often be working with tons of data. The form of this data can vary greatly, but pretty often you can boil it down to a tabular structure, that is, in the form of a table, like in a spreadsheet. Let's have a look at some examples. Suppose you're working in a chemical plant and have a ton of temperature measurements to analyze. This data can come in the following form. Every row is a measurement or an observation, and for each observation, there are different variables. For each measurement, there's of course the temperature, but also the date and time of the measurement and the location. Another example, you've collected information on the so-called BRICS countries, Brazil, Russia, India, China, and South Africa. You can again build a table with this data like this. Each row is an observation and represents a country. Each observation has the same variables, the country name, the capital, the area in millions of square kilometers, and the population in millions. To start working on this data in Python, you'll need some kind of rectangular data structure. That's easy. We already know one, the 2D NumPy array, right? Well, it's an option, but not necessarily the best one. In the two examples we covered, there are different data types and NumPy arrays are not great at handling these. In the BRICS example, the area and population are floats, while the country and capital are strings. For example, your datasets will typically comprise different data types, so we need a tool that's better suited for the job. To easily and efficiently handle this data, there's the Pandas package. Pandas is a high-level data manipulation tool created by Wes McKinney, built on the NumPy package. Compared to NumPy, it's more high-level, making it very interesting for data scientists all over the world. In Pandas, we store the tabular data, like the BRICS table, here in an object called a data frame. Have a look at the Pandas data frame version of the BRICS data I showed you before. You'll see a similar structure. The rows represent the observations, the columns represent the variables. Also notice that each row has a unique row label, BR for Brazil, RU for Russia, and so on. The columns, or variables, also have labels, country, population, and so on. Notice that the values in the different columns have different types. This is all great news, but how can we create this data frame in the first place? Well, there are different ways. First of all, you can build it manually, starting from a dictionary. Using the distinctive curly brackets, we create key-value pairs. The keys are the column labels, and the values are the corresponding columns in list form. After importing the Pandas package as PD, you can create a data frame from the dictionary using pd.dataframe. If you check out BRICS now, we're almost there. Pandas assigns some automatic row labels, 0 up to 4, to specify them manually. You can set the index attribute of bricks to a list with the correct labels. The resulting bricks data frame is the same one as you saw before. Using a dictionary approach is fine, but what if you're working with tons of data, which is typically the case as a data scientist? Well, you won't build the data frame manually. Instead, you import data from an external file that contains all this data. Suppose the bricks data that I showed you before comes in the form of a CSV file called bricks.csv. By the way, CSV is short for comma-separated values. Let's try to import this data into Python using Pandas read CSV function. You pass the path to the CSV file as an argument. If you now print bricks, there's still something wrong. The row labels are seen as a column in their own right. To solve this, we'll have to tell the read CSV function that the first column contains the row indexes. You do this by setting the index call argument like this. This time bricks contains the data frame we started with in this video. It nicely contains the row and column labels. The read CSV function features many more arguments that allow you to customize your data import. Make sure to check out its documentation. Now head over to the exercises to experiment with building data frames yourself.
Okay, I think we can practice for data frame now. So I'll just quickly launch my file here. I'll go to my download section. Now, where do I have my Python for data analysis? So we've covered introduction to Python. That was what we did quite a lot of stuff. Let's go back quick. So the data set is there. So the introduction to Python, we just did intro to Python. So these files are the bricks data file. This brick file, you can find it under the YouTube description. Just follow the link to download it so you can have access to it also. So this is under dictionaries and pandas. I'll probably just rename these files as dictionaries and pandas. So we've covered matplotlib here. So you can go to the matplotlib section from day 8 to learn about matplotlibs. We did some pretty cool charts here with matplotlib. You can see this was from the matplotlib section where we built all these simple charts. We're supposed to use the dictionaries data frame to make it colorful. So I have it here somewhere because in this dict I have it here. So probably I'll just go back to it and use it to make it colorful. So that is by the way though. So I'm after this dictionary notebook. So let me just rename this to dictionaries and pandas. So I can know I have both of them here. So we started learning all about dictionaries from day 8. So we cover all about dictionary. So let me just add a new cell here, and I call this section dictionaries. I want to make it a markdown. So this is dictionary. If I should run on this code, they are working pretty well. So all this was from day 8, so you can catch day 8 to understand all about this code. Oh yeah. So this time let's learn all about pandas. Pandas. I'm going to make it a markdown. Okay. So let's continue here. So it's take dictionary to data frame 1. So Pandas is an open source library providing high performance, easy to use data structures and data analysis tools for Python. So sound promising, right? Cool. So the data frame is one of Pandas' most important data structures. It's basically a way to store tabular data where you can label the rows and columns. One way to build a data frame is from a dictionary. So in this exercise that we follow, we'll be working with vehicle data from different countries. Each observation corresponds to a country and the column give information about the number of vehicles per capita. So, okay, per capita. So whether people drive left or right and so on. So three lists are defined in the script. We have a list here. Okay. We have names. So this is a list. We have DR driving right probably. The driving right to false, 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 true, true. CPC. Okay. Say the names containing the country names for which data is available. So DR is a list with booleans that tells whether people drive left or right in the corresponding country. Okay, that's interesting. So CPC is the number of motor vehicles per 1,000 people in the corresponding country. Okay, so each dictionary key is a column label, and each value is a list which contains the column elements. So this is a list. So let's say import pandas as PD. So I'm going to import pandas as PD. Okay. So create a dictionary my dict with three key value pairs my dict. So let's create a dictionary called my underscore dicts. It says with three key. So we're going to create a dictionary called United States, and we point to the key pair value to false. Okay, so let's see how to do that from our previous lesson. You see here, so we're going to follow this structure here. The country, curly brackets, the country. Okay. Okay, that's pretty straightforward. It says create, okay, let me see, import pandas as PD. Use the predefined list to create a dictionary called my dict. There should be three key values, key dictionary and value names. Key is a country. Okay, I'll just open the curly brackets. What a curly bracket. Key is the country, so United States. United States. Then, and value is the name. It says it should contain three. Drives rights and value DR. Key. Cars per capital and value is CP. Okay. Country. Other minutes. Let's check this. So it should contain three key value pairs. Okay, let's see. I believe you have to follow this technique here, but let's see it in action first. Okay. Okay. It says key, country, and values names. Okay. Okay, understood. So we want to create a key called country. So the value for our country is United States. So the value for our country is United States. So let's see. Okay. Country United States. So the country is going to be our column. Oh, understood. So the key, our next key now. So our next key is going to be, let's see. Key is drives right and value is DR. Okay. Okay. Names. Oh, understood. So I'll just point to the names there. Names after the small names. So the key is drives right. Our next key is drives right. drives underscore right, and the value is going to be this DRA. Okay, understood. DR, okay, correct. And finally, our key is cars per capital. Cars per cap. Then the value is going to be the CPC. CPC. So I'm going to point to that CPC. Just use this list here as my values. So country is going to point to the names or this name list. Drives right is going to point to this DR list here. Then car per capital is going to point to this CPC list. So it's going to extract the value from this CPC list here. So be the data frame cars from my dict. So I'm going to be the data frame from this. So it's going to be data frame is going to be called cars. It's going to be equals to PD underscore read CSV. We're not going to be reading CSV this time around. Okay. So use PD the data frame to turn your dict into a data frame called cars. Okay. So it's going to be PD dot data frame, not read. So we're not reading from a CSV file. You go to PD dot data frame here. And data frame is going to point open brackets to our my dict here. That's called my dicts. Now let's see print class. Let's see if our code is correct. Let's run the code. Oh, you can see we nailed it. Can you see? So from this list, we're able to use dictionary to build a tabular data structure. Now let's see it in action in Jupyter Notebook. I'll just predefine lists. I'm just going to say copy this pattern. Okay, I'll go to my. So I'll just define a list here. Pretty straightforward. Just define a list names dr CPC. So after the list, we're going to import pandas as PD. Pretty straightforward, but I have pandas already. I'll just import it one more time. I have it at the top of my code here. All the packages have been imported there. Let us just run it again. We have imported pandas as PD. Then we're going to create a dictionary from the list. So our dictionary is going to be created from this predefined list here. I think one other I still need to learn about is that 2D numpy. I still want to practice that skill one more time. So we've created a dictionary from here. If I call on my dicts, you can see. So this is a dictionary. We could actually call on it to see. Let me see. So you can call on my dicts. You can see how it is now. You can see the structure now. You can see that it is just scattered. You can see United States, Australia. So United States. You can see the country. United States, Australia, Japan, India, Russia, Morocco, Egypt. Because it is not well structured in a tabular, just like a CSV, just like we have a normal Excel file or CSV file. Like see drives right, it is speaking from this list here. Two, false, 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 two, 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 two. Then we have the other key value here is per capital. It is speaking from this list here. So we're going to use pandas to structure it and make it a tabular data structure. So build a data frame from my dict. So let's build a data frame from that. See, point to it, run the code, working fine. Then finally, we just print cars. In this DataCamp structure, you have to use the print function to see what your data set look like. If I take in Jupyter Notebook, I can just call on cars and just run the code. You can see, voila, we have it in a tabular manner now. But the only challenge now is this row pair value. I think there's a way to get rid of that using, let me see here, setting the index call to 0. You could, I think we could do that. You could just say comma. Let me just give it a shot. Comma index underscore call equals to 0. Now let's run that again. Ooh, error. So I just skip that part for now. Okay. I'll just skip that part for now. And let's keep working with this. I think we nailed it easily. Now let's submit our answer. Ooh, it says, did you correctly define variable my dict? There is no key country. There's a key country here now. I have it absolutely here. Mm, Okay. C country drives rights. Car per capital. I have it right there. But let me see what DataCamp structure is saying. Let's use the AI. Let's just use the AI to get more info about what is happening here. It says create a dictionary my dict with 3 key value pair my dict. You can see country names, drives rights, TR, cars per capita. You can see I beat same structure. It is quite funny sometimes. Let me just copy this part of the code here. You can see I did the same thing. I don't know why this data comes or interface always says I'm wrong. Because I beat the same thing, right? Yeah. My dict country names, drives rights, DR. I can't find funny, so I always double check every time. And there are spaces. So we're actually correct. So let's move on. So good job. Notice that the column of cars can be of different types. This was not possible with 2D non-binary. Yes. The columns cannot be of different. And this was possible because if you have to leave it like this way, we're having issue with conflicts with data types. So if you want to make your 2D array, you can turn this into a 2D array. I think we did that on the matplotlib or introduction to Python chapter. I can't remember. But that is by the way though. We're moving on to the next knowledge. Okay, so dictionary to data frame part 2. It says the Python code that solved the previous exercise is included in the script. So this was our solution to the previous exercise. You can see import pandas as PD. This is the names, the DR drives rights, CPC, the class dicts, cars, which also PD the data frame, then print cars. Okay. Have you noticed that the row labels, the labels for different observation were automatically set to integers from 0 to 6? Or exactly, we noticed, you can see integers from 0, 1, 2, all the way to 6. Okay, to solve this is a list row labels. Okay, to solve this, a list row labels, we have a row labels list has been created. You can use it to specify the row label of the class data frame. You do this by setting the index attribute of cars that you can access as car.index. Okay, that's what I was trying to do there. Okay, well, let's see how to do that. It says it run code to see that indeed the row labels are not correctly set. Okay, let's run the code. So you can see same thing we have from our Jupyter notebook here, on our Jupyter notebook rather. Okay, so it now says specify the row label by setting class.index equal to row labels. Oh, okay. But let's import Pandas as PD as first. Let's import the data frame. Imports. Oh, we've done that already. So import Pandas as PD. Okay, that says specify the row labels by setting cars.index equal to row labels. Let's see how we do that. Specify row labels by setting car.index equals to row labels. Okay, I'm just a cars.index equals to the row labels. Okay, let's see. Now let's print cars. Print full brackets cars. Let's run the code. Aha. Oops. Quite funny. Okay, the row label will now shift from 1, 2, 3, 4 to US, Australia, Japan. Oh, interesting. Now let me see it in my Jupyter notebook. So we're going to define row labels right now. So definition of row labels, we are going to run the code. Okay. So after that, we specify the row labels of cars to cars.index. Okay. Now if you now call on cars here, we should have a beta version. Interesting. So the row labels, we just change the row labels from default 0 to 6 to our own defined row labels there. Interesting. Okay. So that's how to do that. So let's continue. Nice. That looks much more better already. Interesting. Now CSV to data frame. Now let's practice CSV to data frame. So putting data in a dictionary and then building a data frame works, but it is not very efficient. What if you are dealing with millions of observations? So in those cases, the data is typically available as files with a regular structure. One of those file types is the CSV file, which is short for comma separated values. To import CSV data into Python as a pandas data frame, you can use read underscore CSV, open and close bracket to point to the data and to the file paths. So it now says, let's explore this function with the same class data from the previous exercises. So this time, however, the data is available in a CSV file named cars.csv. It is available in your current working directory. So the path to the file path is simply cars. Okay, let me just make it easy also by pointing to the car. So if I go under the car structure here, oh, cool, it is under my directory here, which is cars. You can see it here. So to have access to this file, just follow the link under the YouTube description. So you could download these files, cars, so you can practice along also. So one of the easiest way to point to it is just to, since I have it, the downside is that if you want to have it, if you want to access it easily, just make sure it is in the same directory as you have your Jupyter notebook file. Or you can just go and copy the file part of the file and just paste it. So there are two ways to do this to access the file though. But the easiest way is to make sure you're having my dictionaries and pandas file. You can see it here. I have my CSV file in the same folder on my local machine here. So it is easy for me to read it instantly like that. Okay, to import CSV file, you will still need to you will you will still need the pandas package. Import is as PD. Let's import pandas as PD. No. So now I want to import the cars.csv data as cars. Okay. It's going to be cars equals to PD dot read. I'm going to use PD dot read. So it's going to be PD dot read underscore CSV, open brackets. Okay, so it's going to be import cars CSV. It's going to be cars dot CSV. So we're going to print out cars now. Print cars. Let's go the code. Ooh, we have an error. Okay. Oh, I didn't put my cars in brackets. It's supposed to be in curly brackets. Sorry about that. So I have to put this in curly brackets. Aha. You see now? So we just play the same in our Jupyter notebook here. So we have our import already. We've imported pandas as space. We don't need to be doing that every time we need to point to a data structure. I'll just say cars there is going to be equal to pd dot read csv open brackets double quotes. I think what's the name of it? Which name did I give it? Well, let's see. I gave it cars. Yes, cars.csv. Cars. My car is capital letter, so it's actually case sensitive. Now let's see if we don't have any error. Once I can see no errors. If I come on cars now, oh, this is cars. Okay, this is small letter cars. You see that we have almost the same thing. Yes, exactly the same thing. But this is quite different. This was built from a dictionary. This is our actual file from our local computer here. Interesting. Now let's submit the code. So that's how to run it. Nice job. Looks like, but not exactly what we expected. Let's fix this in the next section. Why? Because of the unnamed, can see unnamed column. This column was actually unnamed. Right from the file. Can see that it gave it column 1 here. Then it also has the index also here by default. But we see this column is column 1, column 2, 3, 4. We have 4 columns in our data file here. So CSV to data frame part 2. So your read CSV call to import the CSV data didn't generate an error, but the output is not entirely what we wanted. So the row labels were imported as another column. Okay, that's true. The row labels here. Without a name. Interesting. Remember index column an argument of read CSV that you can use to specify which column in the CSV file should be used as a row label. Well, that's exactly what you need here. Okay, so the index column is just for you to specify which column in the CSV should be used as a row label. Interesting. You can say, okay, index column should be column 1. Oh, interesting. Well, that's exactly what you need here. Python code that solved the previous exercise already long included. You can make the appropriate change to fix the data imports. So run the code with run code to assert that the first column should actually be used as row labels. Okay, let's run the code first. So this is our first column. It's supposed to be used as a row labels. So specify the index column argument inside pd.read underscore csv. Set it to 0 so that the first column is used as row labels. Okay. The index column. Okay, we have to point to fix import by including index column. So index underscore call should be equal to 0. Okay. Let's print it out again. Aha. So it's worked fine. So I start to use this same time in my CSV code here. Right here. Okay. Just right here. I don't know why it didn't work there. So let's try it again here. Let's say underscore index column should be equal to 0. Interesting. Works fine. You can see. Column 1 should be our index. Then we have this car per capital, country, and drives rights. Interesting. So that's pretty straightforward there. We are nailing it. So Pandas is pretty simple and easy like this. That's quite straightforward and interesting. Okay. So, okay, Pandas part 2. We have a part 2 section, square brackets, lock and iLock, lock and iLock, lock and iLock. Let's see what we have to learn again in this Pandas part 2 section. Oh, we're like 40 minutes into the live. I think we could just complete the Pandas uh, section today. We just complete the Pandas section and we move to the next chapter on day 10, I guess. So let's continue the Pandas lesson.
In the previous video, we created the data frame bricks containing basic data on the BRICS countries. Here it is again. The code here makes sure that the rows and columns are given appropriate labels. This is important to make accessing columns, rows, and single elements in your data frame easy. Now, that's exactly what I'll show you in this video. What a coincidence! There are numerous ways in which you can index and select data from data frames. So we'll take this step by step. First, I'm going to talk about how to use square brackets. Next, I'm going to tell you about advanced data access methods, loc and iloc, that make Pandas extra powerful. Suppose that you want to only select the country column from BRICS. How to do this with square brackets? You simply type BRICS and then the column label inside square brackets. Python prints out the entire column together with the row labels. But there's something strange here. The last line says name, country, dtype, object. We're clearly not dealing with a regular data frame here. Let's find out about the type of the object that gets returned with the type function as follows. Okay, so we're dealing with a Pandas series here. In a simplified sense, you can think of the series as a one-dimensional array that can be labeled, just like the data frame. Otherwise put, if you paste together a bunch of series, you can create a data frame. If you want to select the country column, but keep the data in a data frame, you'll need double square brackets like this. If you check out the type of this fellow, it's a good old data frame, this time with only one column though. You can perfectly extend this call.
Cool. Hold up. Let's go back a little bit again.
In the previous video, we created the data frame bricks containing basic data on the BRICS countries. Here it is again. The code here makes sure that the rows and columns are given appropriate labels. This is important to make accessing columns, rows, and single elements in your data frame easy. Now, that's exactly what I'll show you in this video. What a coincidence! There are numerous ways in which you can index and select data from data frames. So we'll take this step by step. First, I'm going to talk about how to use square brackets. Next, I'm going to tell you about advanced data access methods, loc and iloc, that make Pandas extra powerful. Suppose that you want to only select the country column from BRICS. How to do this with square brackets? You simply type BRICS and then the column label inside square brackets. Python prints out the entire column together with the row labels. But there's something strange here. The last line says name, country, dtype, object. We're clearly not dealing with a regular data frame here. Let's find out about the type of the object that gets returned with the type function as follows. Okay, so we're dealing with a Pandas series here. In a simplified sense, you can think of the series as a one-dimensional array that can be labeled, just like the data frame. Otherwise put, if you paste together a bunch of series, you can create a data frame. If you want to select the country column, but keep the data in a data frame, you'll need double square brackets like this. If you check out the type of this fellow, it's a good old data frame, this time with only one column though. You can perfectly extend this call to select two columns, country and capital, for example. If you look at it from a different angle, You're actually putting a list with column labels inside another set of square brackets and end up with a sub-data frame containing only the country and capital columns. You can also use the same square brackets to select rows from a data frame. The way to do it is by specifying a slice. To get the second, third, and fourth rows of bricks, we use the slice 1:4. Remember that the end of the slice is exclusive and that the index starts at 0. Here are the row indexes so that you see what's happening. These square brackets work, but it only offers limited functionality. Ideally, we'd want something similar to 2D NumPy arrays. There, you also use square brackets. The index or slice before the comma referred to the rows. The index or slice after the comma referred to the columns. If we want to do a similar thing with Pandas, we have to extend our toolbox with the loc and iloc functions. Loc is a technique to select parts of your data based on labels. Iloc is based on position. Let's start with loc first. Let's have another look at the bricks data frame and try to get the row for Russia. This is how it's done. You put the label of the row of interest inside square brackets after loc. Again, we get a Pandas series containing all the rows' information, rather inconveniently shown on different lines. To get a data frame, we have to put the RU string inside another pair of brackets. We can also select multiple rows at the same time. Suppose you want to also include India and China. This will do the trick. Simply add some more row labels to the list. This was only selecting entire rows. That's something you could also do with the basic square brackets. The difference here is that you can extend your selection with a comma and a specification of the columns of interest. Let's extend the previous call to only include the country and capital columns. We add a comma and a list of column labels we want to keep. The intersection gets returned. Of course, you can also use loc to select all rows, but only a specific number of columns. Simply replace the first list that specifies the row labels with a colon, a slice going from beginning to end. This time, the intersection spans all rows, but only 2 columns. So, let's take a step back. Simple square brackets work fine if you want to get columns. To get rows, you can use slicing. The loc function is more versatile. You can select rows, columns, but also rows and columns at the same time. When you use loc, subsetting becomes remarkably similar to how you subsetted 2D NumPy arrays. The only difference is that you use row labels with loc, not the positions of the elements. If you want to subset Pandas data frames based on their position or index, you'll need the iloc function. Let's cover the same examples as with loc and start with getting the row for Russia. In loc, you use the RU string in double square brackets to get a data frame, like here. In iloc, you use the index 1 instead of RU. The results are exactly the same. To get the rows for Russia, India, and China, which was coded like this when using loc, you can now use a list with the index 1 to 3. Again, the same result. In addition to only keeping the country and capital column, which we did as follows with loc, we put the indexes 0 and 1 in a list after the comma, referring to the country and capital column. Finally, you can keep all rows and keep only the country and capital column in a similar fashion. With loc, this is how it's done. For iloc, it's like this. Loc and iloc are pretty similar. The only difference is how you refer to columns and rows. I know all of this could be a lot to take in. So let's get you coding yourself to master indexing and selecting data. Keep learning by doing.
Oh, I think this part is quite a lot to take in today. Probably we'll just come back on day 10 and complete this part. Ooh, as we have quite a lot of challenges here to complete. So we'll just stop here and finalize this Pandas part 2 on day 10. So do want to practice Pandas part one pretty well so you can understand. So we need to come back to this look indexing on Pandas. We see of there. So I just end the live stream right now. Alright, so thanks for staying to the end of the live stream. So if you found value in this learning journey with me, I'll do what to support the channel by giving the video a thumbs up, hit that subscribe button, and put on the notification bell so you'll be the first to know whenever I go live or drop a new content on the channel. So do make sure to practice Pandas that we learned all about today. So get the file, the cars data file under the YouTube description. You should have a link to all the files so you can practice. So as usual, I'll see you tomorrow, day 10, as we complete this section on Pandas, which is advanced Pandas to me. Kind of advanced Pandas to me. Understanding the indexes, high lock, and how to use it to what? To get certain columns and rows in your data or your data structure. So right, I'll see you on day 10. Voila. Hasta la vista. Is that a correct thing to say? I don't know, by the way. I'll see you on day 10. Do not forget to subscribe. Hit that subscribe button right now so you can know whenever I continue learning Python.